Okay, let's look at this very interesting question. I think most of people who first look at this question can easily make a mistake. The problem is Alice told Mr. Clever that her uncle David only have two kids, Peyton and Skylar, with at least one of them is a boy, but we don't know who is the boy. And given equal chances for each kid to be a boy or girl, and the gender of them are independent, what is the probability that both children are boys? I think we can easily think in this manner that given that there's already one kid is a boy, hence if the other kid is a boy, then both of them are boys. And given that we have equal chance for each kid to be a boy or girl and the gender are independent, it is easily concluded that both kids, the probability of both kids are boy are 1/2. But this answer actually are wrong. If you want to think about it, probably you want to pause the video. Next, I'm going to go through with you the correct solution. Actually, we can use two-letter sequence to represent the possible outcomes. We use B to denote boy, and use G to denote girl. And if a sequence BG basically means that the first kid is a boy and second kid is a girl. Hence, we can use GG to represent two girls, and BB represent two boys, and GB to represent the first kid is a girl and the second kid is a boy. So our sample space will be these four possible outcomes. And given that equal chance for each kid to be a boy or girl and the gender of each kid are independent, then we can see that each outcome in this particular sample space actually are equally likely. They are uniform distributed. Hence, we know that the probability of BB, BG, GB, and BB are all 0.25, which is 1/4. And we can denote both kids are boys as a event X, which have only one outcome BB. And at least one kid is a boy as Y, which have three possible outcomes BB, GB, and BG. Hence, if one kid is a boy, the probability that the other kid is also a boy actually is a conditional probability. So basically, it's the probability of X given Y. And we can directly apply the conditional probability formula. PA condition on B is equals to PA intersect with B divided by PB. Hence, we can get the probability of X intersect Y divided by probability of Y. We can just reason a little bit. X denotes the outcome that both are boy, and Y denotes that is at least one boy. The intersection of these two sets are only one element, which is the probability of that both of them are boy. And the probability of even Y actually is quite straightforward. Since this set contains three outcomes and each outcomes are mutually exclusive, and each possible outcome have a probability 0.25. Hence, the probability of even Y basically is nothing but the sum of the probability of each individual outcomes. Hence, we can get the outcome is 1/3, which is different from our intuition that it should be 1/2. And you can just think a little bit. Actually, the reason why it is counterintuitive is that we don't know whether Y is the first kid or the second kid. If let's say we know that the probability X given that the first kid is boy, then it can become the probability of BB divided by the probability of BB plus the probability of BG. Then this will be 1/2. That is aligned with the intuition. Hence, the key difference is that if we know which kid is a boy, then we can say that the other kid is also a boy, the probability is 1/2. But we don't know which kid is a boy, then we will have three scenarios. Either both are boy, or the first kid is a girl, the second kid is a boy, or the first kid is a boy, or the second kid is a girl. Hence, sometimes we cannot just solely rely on our intuition to make the quick judgment. It's better always for us to properly formulate the problems and define the sample space properly, and then calculate the event mathematically to verify our intuition.